So if you are watching this video because you missed class today, I started the video after going through this first paragraph. So please read the first paragraph and look at the picture. Apologize. The graphs right here are showing a point of a tangent line at a particular point on each of these graphs. Remember, tangent only crosses through the graph one time. So now, when we talk about circles, when we talked about circles in geometry, it only crosses through the circle one time. But when we talk about graphs, we have a problem because it doesn't only cross through one point in every single graph. Some graphs it will, but look at this middle graph here. If I extended my line, it's not gonna be perfect, but if I extended this line, eventually it will cross the graph again because the graph does fun things and it twists and it turns. So we can't just call it like a point of tangency the way we would call that in geometry to a circle. So it's not necessarily just one point. So what we're really going to do is we're going to like say it's tangent maybe within a certain range or a certain domain, certain restriction. Okay. So the slope of the graph, because the tangent line approximates the graph at a point, the problem of finding the slope of the graph at a point becomes finding the slope of the tangent line at the point, which is, I already said that earlier. So we're going to look at this graph and you're going to have a couple questions that are just approximating. This is not going to be super accurate, and they will make it really easy for you because they've drawn some of it for you. There is part of f of x equals x squared, and then they drew a line in for you. And we just have to figure out, what do you think the slope is at this particular point on the graph? What do you think that tangent line slope is? Anybody? 2, because to find the slope, we do the change in the x. Nope, we don't. We do the change in the y over the change in the x. And the change in the y is 2, change in x is 1, and we get 2. All right, has anybody seen delta x or delta y before? Has anybody seen these? Just curious. Where? Where? Oh yeah. Do you know what they mean? It means change. Delta is like the difference. It's the change. So when we see delta, we're going to talk about change. Either x or y, whatever variable it is in front of. The delta is a Greek symbol. That means the change in, and then I'll just put x, but it could be y. We should also be able to interpret our slope. So here's like a real life example. You can't see the question or the paragraph right now, but I'm just going to summarize. This is a yearly average temperature for Duluth, Minnesota. And you would expect it to be warmer in the summer and colder in the winter. And we are going to find the slope of this tangent line that goes through this point. And that point is like between October and November. So we're going to find the slope, and then we're going to discuss what that would mean according to this real life situation. So who could tell me what the slope of the tangent line at this point could be? Madeline. So negative 27 over 2 is totally fine. That's exactly a slope. In order to talk about it in real life situations, probably going to change that into either a mixed number or a decimal, which is negative 13.5. Because what is happening? What does negative 13.5 mean? Degrees what? It's Fahrenheit, first of all, but degrees what? What's happening from October to November? Why is there a slope at all? Okay, one person, because I can't tell what's happening. Megan. There is a change in temperature over the months. Let's be more specific. From October to November, the average temperature does what? What? Did you say decrease? By how much? Right. From October to November, the average temperature is going down by about 13.5 degrees. This is not super accurate. We're using a line that we just stuck in the graph and found some points to make the slope with. Okay. But it's a start. So because it's not accurate, mathematicians had to play around with this to try to get something that is more accurate. I'm going to go through this in a second, this like crazy looking formula that you've probably seen a few times now. I'm going to go through that in a second, but I'm just going to talk about this picture first. So if I know 2 points on the graph, which I can easily find 2 points if I have an equation. If I have an equation, I'll plug in some x's, I'll get out some y's. I can definitely find 2 points on that graph. If I find 2 points on that graph, I can have a line that passes through 2 points, and I know that line is accurate. Because in geometry, 2 points make a line, right? 1 point makes all kinds of lines, and the slope, it depends on the slope at that point. But this has a slope. It has a location. Like we could definitely accurately do this. Now, looking here, we've got a point that we're labeling as x comma f of x, xy, or x comma f of x. This other point, oopsies, this other point is going to be, start with this x. This other point is start with the x, but add on some change. So right here, the x is now x plus something, x plus delta x. And the delta x measurement is from here to here, whatever I added on to get a new x value. So if this is my new x value, x plus delta x, when I put it into the function, I would get f of x plus delta x. So that is the symbol showing that that's the output when I put in the x value. So that's my y value. So that's why they have that written that way, because we don't have an actual function. Okay, and then over here on the side, this would be the function, the y value of the top point, but subtract the y value of the first one. That's how far up this graph is from here to here. That length is the y value of the top one, subtract the y value of the second one. So that's where all these symbols are coming from. Okay, now what's going to happen, and this you're just going to have to watch because I'm going to touch this graph and move it. What's going to happen is we're going to use limits. We're going to use a secant line like this, then we're going to use limits, and we're going to take this line and we're going to, I'm going to move the line a little bit so I can do this. Okay. It's still a secant line. I just made it so it doesn't go past the bottom of the graph. So I'm going to take this end up here and I'm going to use limits, and I'm going to make the delta x smaller. So what I did when I put a point here is now my delta x is smaller than the first delta x. Then I'm going to take it and I'm going to move it again. Oops, not move the whole thing, just this point. And now my delta x is getting smaller. Green. So now the point is here and the delta x is even smaller. Do you understand what I'm talking about? Where I'm talking about the delta x, the change from the original x to the new x is getting smaller as I'm taking this graph and I am moving it down. So now here the delta x is getting smaller. Smaller delta x. eventually, as my delta x goes to being 0, as my delta x is going to 0, so here's limits. As my delta x is going to 0, so as this red line and the point where delta x is just getting shorter and shorter and shorter and closer together, eventually when delta x hits 0, we will have that tangent line. So this is what's happening, and we're going to do it mathematically. We're not going to do it with a line. We're going to do it mathematically. This is what's taking place, is we're going to use an equation, and we're going to find the limit as delta x is approaching 0. So we're going to find the limit of delta x getting smaller and smaller and smaller and smaller and smaller until it is nothing. And then we will have the equation that we desire. Questions about what I'm visually doing? So now they have that shown in like 4 graphs here, what I was doing, only it's not moving. So you just have to imagine the same thing that I was doing. Here, the delta x is getting smaller and smaller until it's nothing. And then we have the point of tangency, and we have that tangent line. So to get there, algebraically, we're going to use the slope of a secant line, which is subtract the y's, subtract the x's. The slope of the line, y2 minus y1 over x2 minus x1. We're going to use that equation. So y2 would be the f of x plus delta x. That's y2. y1 is f of x. X plus delta x is x2. And then x1 is x. So that's what we're doing right here. We're doing y2 minus y1 over x2 minus x1. We're finding the equation of the slope. When we do that formula, we get this equation with all the delta x's. And that is equivalent to the change in y over the change in x, which is what I wrote right here. Okay, so that's where this formula is coming from. Questions about where the formula is coming from? So what's delta x? The change in x. It's from the point that we want to find to however further out the secant is. Oh, this formula is called the difference quotient. So if you see the words difference quotient, that's what this formula is that I just put a big fluffy cloud around. That's called the difference quotient. Okay, so here we're going to do an example. We're going to find the slope by the limit process. So here we have an equation, f of x equals x squared. We're going to find the line that is tangent to -2, 4. So we're going to use that difference quotient that we just had, which is f of, is it x plus or delta x plus? I already forgot the order. X plus. Thank you. And then we're going to subtract off f of x. And we're going to put that over delta x. And then from there, we will take the limit as delta x approaches 0 of this difference quotient so that we can find the tangent. So that -2, 4, that's like my x2, x, no, that's like my x and my y. Just kidding. That's my x and my y. Okay. So this is my x and my y. Every place I see an x, that should be a -2. So we'll have f of -2 plus delta x minus, what's f of x? What? Mm-hmm. it's 4. The f of x that goes with x is what I meant, not just in general, but it'll be 4. Because we're specifically talking about 1 point. So this is our x comma f of x. I wrote y. I should have written f of x. Okay, and then that's going to be over delta x. Now, remember when we have something like f of -2 plus delta x, that means replace x in the function f of x with -2 plus delta x. That's the directions. If it says f of -2 plus delta x, that means take out x in the function, put in -2 plus delta x. So my function is x squared. That's my function. So I'm going to now do limit x approaches 0. And I have f of -2 plus delta x. I'm going to do -2 plus delta x squared, because my function says take x and square it, minus 4 over delta x. Now I'm just going to multiply that out, simplify it. At this point, oh, you know what, you guys, I keep forgetting to do this. This should say delta x approaches 0, not, oh, it did say it, and then I forgot to keep writing delta x, sorry. Should say delta x for all of those approaches 0. So at this point, when we say delta x approaches 0, if I just plug in 0 right now, we're going to have a problem because the denominator would equal 0. So it's not really telling me any information. So this is where we're going to want to simplify it and see if maybe that delta x can go somewhere else. So we'll have the limit as x delta x approaches 0. And I'm going to multiply that out. So I'm going to get 4 minus 4 delta x times x plus delta x squared minus 4 over delta x. So on top, the 4s, they cancel each other out. I'll have -4 delta x times x plus delta x squared over delta x. And what should we do next? Emily?
Separate the delta x squared times delta x times delta x, and then the denominator will cancel out.
Okay, so I'm going to use a different phrase than you did. I'm going to say factor out the delta x on top. So I have delta x multiplied by -4x plus delta x over delta x. I've done something wrong. I have something extra. There shouldn't be an x in the middle. I think I'm thinking of a different example. Sorry. Okay, so factor out that delta x. And then we can cancel it, like Emily said, cancel that. So now I have the limit as delta x approaches 0, and I have left over -4 plus delta x. So I did what I needed to do. I got delta x out of the denominator. So now if I plug in 0, what do I get? I get -4. So our goal was to get the slope of the line at a particular point. And we got a number that seems like a slope to me. If I look at the graph, -4, I feel like that could be an answer. I mean, I could draw the lines in here and actually go down 4 over 1 and see if that fits. Kind of looks like it does, doesn't it? Down 4 over 1. So -4 would be the slope. Okay, so we're going to do that a couple more times. They have different situations too, where this example is not going to be find the slope at a particular point. This is going to be just find the slope of the graph. Now, what kind of graph is this? Line. So you should tell me right now, what is the slope of this graph? What? -2. Now we're going to do it using this formula just to practice the formula. We already know the answer. So we're going to find the slope of this line by using the limit as delta x approaches 0. And we're doing the formula that says f of x plus delta x minus f of x over delta x. So this one is different than the first one because we are doing the entire equation. So when I go to do f of x plus delta x, I'm not going to plug in a number. F of x plus delta x, x is the input. X is the input already, if it's just the equation. On the last equation, it was -2, -2, you have to plug in. So here I'm just plugging in x, and it's, I don't know why it's doing that. I'm just plugging in x and into my equation, which is -2x plus 4. So I'm going to replace with x, I'm going to replace x plus delta x. So we will have -2 times x plus delta x plus 4. So that's the first part. Minus, it says f of x, which is -2x plus 4 over delta x. So for this one, because it wasn't a specific point, we basically use the entire function. Oh my gosh, I don't know why that keeps happening. So let's simplify. On top, we get -2x plus -2 delta x plus 4 plus 2x minus 4 over delta x. And we look for some stuff to cancel out. So now I have the limit. Oh my gosh. The limit as delta x approaches 0, and I have -2 delta x over delta x. So when I do that, I've got the limit delta x approaches 0 of -2. So now there's no place to plug in 0, but the answer is just -2. And you told me already, well, the slope has to be -2 because it's a line. So we already knew the answer, but going through these steps, you can still find it. Not that you would do that for this one. So the difference between example 3 and example 4, example 3 is at a particular point. Example 4 is when you do it for the function. So you have different ones like that in your assignment. So we're going to find the formula for the slope of the graph, but this time the graph is not a line. And this is going to work for any point on the graph. And then we'll prove it by finding the tangent slope at different points that are definitely different slopes. So we're going to do the formula for the slope of the graph of f of x equals x squared plus 1. So we'll start with limit as delta x approaches 0. And we do f of x plus delta x minus f of x over delta x. So I'm going to start and I'm going to plug in my function. Limit as delta x approaches 0. And wherever I see an x, I'm going to replace that with x plus delta x squared plus 1 minus the function x squared plus 1 over delta x. So multiply stuff out. This is the one where I got confused with the first one. This is the one that has the extra x in it. So x squared plus 2 delta x times x plus delta x squared plus 1 minus x squared minus 1 over delta x. And then stuff's always going to cancel when you do this. So the limit as delta x approaches 0, we've got 2 delta x times x plus delta x squared over delta x. So if you can see something cancels right now, you can go ahead and cancel it. If you don't see it, I will show the step in between. So I'm going to pull out a delta x, and we'll have 2x plus delta x over delta x. And those cancel. And so I'm doing the limit as delta x approaches 0 of 2x plus delta x. So what is my slope of the equation? I get 2x. So by using that, I'm finding out that my slope of the equation is 2x. So now it says, let's find the slope at these particular points. So at tangent line at -1, 2, I'm just going to plug in x. And I'm going to say my slope at that point, I'm going to do 2 times -1. And the slope for that point is -2. And you could go over here and go -2 over 1, and it works. And the slope at the point 2, 5, I'm going to plug in 2. And I get a slope of 4. And so I could use up 4 over 1, except for I'll be off the graph, but I could use down 4 over 1, and I will still be on that line. It's going to work. So I'm finding the slope at any point, and then I can plug in those points if I need to. And that is the end of today's stuff. You're just going to do a bunch of those for homework, for your assignment. Oh, it's pretty exciting, huh?